The learning target for today is up on the board. It says I can find arc lengths, and it gives you the formula. It says AL equals circumference times ratio. If you look ahead, you can see that Monday or Tuesday of next week it'll say I can find sector areas, and it's basically the same formula. Instead of circumference, however, it says area. So knowing these formulas and getting comfortable with them and being able to manipulate them is going to be very important. If you would like to do well on this test right here before spring break, it would be very good to be able to manipulate this formula correctly. Okay? First couple things I need to talk about. I need to remind you that the circumference formula can either be 2 pi r or what else? Pi times what? Diameter. So if they give you the diameter, you use pi times diameter. If they give you the radius, you use 2 pi r. Typically, they give you the radius, so the formula that I plug in to the arc length formula is right here. But this could also be pi times diameter. Okay, go ahead and copy this formula down. Right, this is the arc length formula. This is, sometimes you also see it with a C right here. Right? Circumference equals 2 pi r. So, you know, sometimes you see, also, sometimes right here, you see the word ratio. Right? We're going to talk about that in detail. But sometimes you see the word circumference, or the letter C. Sometimes you see ratio. Right? I've kind of taken it the next step down and said, what do we need to know in order to be able to find the arc length? Okay? Before we do that, and before we talk about arc length, I need to talk about a couple of things. Minor arc, right? What is a minor arc? What is a major arc? Okay, and then what is a straight arc? Okay, a minor arc is less than 180. A straight arc is equal to 180. 180 degrees, right? And a major arc is how much? It's greater than 180 degrees. Okay, I'm kind of abbreviating there, but that's important. More important than major, I'm not ever going to ask you, is this a major arc or is this a minor arc? But I am going to be giving you letters. And you need to know the difference between these things, what they could be, and what they cannot be. And what does this mean? That's arc over 2 letters. Well, that means that it's a piece of a circle, right? The curved surface of a circle is an arc, right? And so if we're talking about from A to B right here, that is a minor arc. Okay? Minor arcs, this is very important. I know I'm talking fast, I'll slow down. Minor arcs always have, they must have 2 letters. Okay, minor arcs have 2 letters. They can have 3 letters, but if I say AB, I know as a teacher and as a student that I'm talking about this short distance from A to B. So nobody can get confused and say, oh, he meant from here all the way around to there. Nope. What would from A all the way around to B have to be? It would be greater than 180, right? And so what must it be? A major arc has to have 3 letters, right? It must have 3 letters so that we know that we're talking about either a straight arc, right? Straight arcs also have 3 letters, or a major arc. Straight arcs and major arcs must have, kind of weird, straight arc. That's probably not the correct word for it, but it equals 180. I'll show you an example. 3 letters is always a major arc. Can you name a minor arc with 3 letters? Sure you could. If I said arc ACB, right, that would be the same as AB. I've just stuck a letter in there. Most of the time we don't do that. Most of the time with minor arcs we just say 2 letters. Okay? But I could call it 3 letters if I wanted to. But if you see 2 letters, you have to come up with the same arc as me, otherwise we're getting different answers. Okay, let's do some more examples. Alright, here we go. A, B, C, C, D, and E. Okay? This is a straight line. This is the only straight line right here. So AD. What is AD? What's wrong with it? Why is AD incorrect? AD is from here to here. But do I know if it's the top arc or the bottom arc? No. So you can't name straight arcs with just 2 letters because I don't know. I don't know if you meant this travel or this travel. So straight arcs have to be 3 letters. That's why I put 3 letters, straight arc. It would have to be AED. Arc AED is correct. Why? Why is that correct? Because it tells you in a direction, right? Is it the top arc or the bottom arc? Why? Because of the E. AED is this bottom straight arc, right? Or half arc. I think it might be called a half arc. We don't do them very often, but it's neither here nor there. You need to know that AED is right there. Okay? How about this? How about AC? Arc AC. Is that okay to say arc AC? Could you come up here and every single person in the room know the correct arc and be able to draw the arc? Yes, because I only use 2 letters, I know that it's not from here to here. That arc AC has got to be this arc from there to there. Perfectly okay. Arc AC. I could call it arc ABC, but I don't have to. I can just say arc AC. I can skip over it. Say it again. Because it's only 2 letters. And when I see 2 letters, I have to say the shortest path, the minor arc. Okay? That way you and I are talking about the same thing. Great question. Yes, ma'am.
So if it's ABC, does that count as a minor or a major arc? If it's 2 letters.
They are exactly the same thing.
So would it be minor and major minor?
Minor. So minor arcs can be 2 letters or 3 letters. Most of the time they're 2 letters, but it can be 3 letters. Okay? Can a major arc be 2 letters? No, it cannot. Okay? So when I say A, D, C, does everybody know which arc I'm talking about? ADC. Is there any discussion about what arc that is? Is it a major arc or a minor arc? Why is it major? Because it's more than 180. Here's ADC. So it would be from here all the way to there. That would be arc ADC. Why does it have to be major? Why can't it go in this direction? Because the ADC is telling you which direction to go. Questions? It's a very easy concept. I just have to talk about it at least one time for you to get it and make sure you've got it. Questions? All right. Now I need to talk about central angles. I'm going to leave my circle up here. Central angles. If you look, this is actually a learning target from the next section. It says, I can use central angle properties to find missing angles in circles. Well, that may be true. We're not going to use central angles to find missing parts today, but you need to know the relationship between the central angle. If this is the center of the circle and I make a minor arc from A to B, if this measurement is 60 degrees, if I put a protractor up there and I said that that measurement of that angle is 60 degrees, it has a 1-to-1 correspondence into the measurement of the arc. From the measurement of the arc from A to B, the angle measurement or the measurement is 60 degrees as well. This number and this number have a 1-to-1 correspondence, meaning they're always the same. Another way of saying that is central angles measurement are the same as the arc measurement. This is where it's confusing though. When I start talking about arc length, right? Arc length is what we're finding today. Arc length, right? And I do the same thing and I got A and I got B. Arc length is this measurement from here to here. If you were an ant and you walked from A to B, that's arc length. And it could be like 6.2 centimeters. So if this is 60, this is also 60. This is what's confusing. AB can have two different measurements, right? It can have a ratio of the entire circle. That's what the 60 is. It can also have a length, like 6.5 centimeters. Okay? Here, this helps. What's all the way around the circle?
360.
360. So this is a relationship to all the way around the circle, right? This AB is also a relationship to all the way around the circle. This 60 matters, okay? It is very important to being able to find arc length. The reason that we have two measurements is because here's your radius, right? What if the radius was 2? Then this distance from here to here might not be very much. But what if the radius was 200? Then what's the distance from A to B going to be? It's going to be quite a bit more. Quite a bit more. All right, here's a question. If this is 60, then what does this have to be? 60. If this is 80, what does this have to be? Why? Because they're all central angles. If this is 60 and this is 80, right, that's 140. This would have to be 40. Why? Because it makes a straight line, right? So what does this have to be? It has to be 40. So these three arcs have to add up to 180, and these three angles have to add up to 180. That's not a mistake. If I gave you this angle and I said that it was 100, right, then what would this angle have to be? It would have to be 80. What do all 5 of those add up to? 360. So this one's 80, this one has to be 80. What about this? If this is 100, does this have to be 100? Sure it does, right? The arc measurement and the angle measurement have to be the same. Okay, I hope I haven't lost you there. It's a pretty easy concept. It's just kind of weird that this can have two different measurements. How about this? If you're on a record, right, a vinyl record, everybody likes vinyl now, coming back in style, and you're sitting right here at point A and you're sitting right here at point B, and I start the record. You're an ant and you're sitting on a record, and I push play or whatever you do, on. Who's moving faster? The person standing on point A or the person standing on point B? Or are they moving at the same speed? Who's moving faster? Is the person in the middle moving faster? The person on the edge moving faster? Or they're going around, are they moving at the same speed?
The outside's faster.
Why?
Would be covering more distance.
Outstanding answer. Right? Think about a merry-go-round. Right? When you're on a merry-go-round, you stand in the middle or you get closer to the middle, what happens? You're not moving as fast. What happens if you move out to the edge of a fastly moving merry-go-round? Right? You start you fall off because you're moving much faster. And Ross is exactly right. The person in B, the person standing on B is moving much faster because they have more distance to cover. Why? Because the radius is more. This radius and this radius is quite a bit different. So this arc length is more. Think about a track. Right? Lanes 1, 2, 3, 4, 5, 6, 7, 8. Who gets the advantage at the start? Not really an advantage, but it's called a staggered start, right? It looks kind of like this, right? Lane 8 starts way out here. Why? Because it's further in lane 8, right? When they come all the way across the finish line, what happens? All 8 of them have run exactly 400 meters, right? If you're just doing one lap, right? A track, lane 8 has to have a staggered start. Okay? Because it's much further out there in lane 8. Why? Because the radius changed. Okay? Alright, so now that you're thoroughly confused, let's do a few problems. Here's your formula. Arc length equals circumference times ratio. I have a missing value here, a missing value here, and a missing value here. There are 3 missing values in that formula. And I can give you, or I'm going to give you 2 out of the 3. Write that down. They're always going to give you 2 out of the 3. They're not going to give you 2 missing values. You wouldn't be able to solve it. Okay, the easiest one that I can give you is the radius and the ratio. Right? That's what we're going to start off with. Okay, so here's your first example. Right, here's the center of the circle. Here's A and here's B. The measurement of this arc is 120 and the radius is 13. We're finding the measurement of AB. This is an arc length problem, as easy as it gets. They gave, no, hold on, don't get your calculators out. They gave you the ratio, okay? They gave you the radius, right? And they asked you to find the distance. This is what this is saying, so that we're all on the same page. When I say AB, everybody has to know that it's this short distance from A to B. It's not the long distance. Why? Because I just used 2 letters. Okay, that denotes minor arc. All right, AB. Well, let's plug it in the formula. 2 times pi times 13. Why did 13 go right there? Because it's the radius. The radius goes in the formula right there. How about the ratio? What is the ratio in this problem? 120 over 360. Why? That's the part of the circle. If the central angle is 120, then the measurement of this arc is also 120. It's the piece of the circle. We're not doing the entire circle anymore. If I wanted the entire circumference, right, if I wanted all the way around the circle, it'd be 360 over 360. What's 360 over 360? 1. And the circumference times 1 would just be the circumference, right? So this is telling me I have a part of the circle, or a ratio of the circle. And this number changes, right? If this number changes, then this number changes. If this number changes, this number changes. It's that simple. Okay, everybody get your calculator out. Plug and chug. Use parentheses. You need a calculator?
Oh, no, I did that.
All right. Plug it in. I'm going to plug it in on my calculator. You need one, Barry? You got one? There you go. I'm out. Look around.
Which one are you?
Yeah, there you go. Pass it over. Don't hit the pen. All right, so here we go. Parentheses. 2 times pi times 13, parentheses, 120 divided by 360, close parentheses, equals. I could get, if I wanted to, I could get 26 pi over 3. You know, either like this or all over 3. I'll do it all over 3. That would be the exact answer, right? This calculator gives me in terms of pi if I wanted to. Then I hit decimal, and what is the decimal? Approximation. 27.23, is that rounded like money? 27.23. Anybody not get that on your calculator? Anybody not get that on your calculator? Here's your chance to practice. What's imperative that you use? Parentheses. If you don't use parentheses, you can hang it up. You are not going to get this problem right. Okay? You might accidentally, but consistently, you've got to use parentheses. This would be the exact answer. This would be the rounded answer. Okay? Questions? All right. You ready for the next example? All right. Let's do another. Man, look at that circle. I'm telling you what. Here's A. Here's B. Here's this angle measurement. And the radius is 7. Find AB.
270.
Uh-huh. Find the measurement of arc AB. All right, Clark, tell me what to write down.
Alright, put it there.
Parentheses, yep.
2 times pi times 7
Why 7? You're right. Why?
is the radius.
Okay, very good. Then the most important part, this ratio. Will it always be some number over 360? Will it always be some number over 360? Why? Because that's the formula. Right? It's always some number over 360. The important part is what's the number? Clark. I'm not sure about that. Why 90? It's 90 right here. Why? Because this is this arc. I don't want to know this arc, right? 270 matches up to this, right? I asked you for this arc, AB, and this has to be a right angle. It has to be 90 degrees, right? You had to subtract from what? 270 from what? Why 360? That's all the way around the circle. The most it can be is 360 if you just do one revolution. So you type that in. That was tricky. All right, let's do it exact, right? This is 14 pi. This is how much? 1/4, right? 1/4 times 14 pi, I can take a 2 out and get 7 over 2 pi. Right? That's it by hand. I don't even need a calculator. If the directions say leave it exact, that's it. Okay, if it doesn't, then I do 7 pi divided by 2 or 3.5 pi. And what do I get? What is the approximation decimal for this?
About 1099.
How much?
1099.
1099? All right, here's a question. If this is in inches, let's just say that it's in inches. It could be centimeters or meters or miles or kilometers or whatever. What is this in? If this is in inches, is this inches squared, inches cubed, inches? What is it in? It's just in inches. Why? Because it's just a distance. I'm not squaring anything. I'm not finding area. I'm not finding volume. It's just plain old inches. Okay? Now, why was that a little tricky? Yeah, because I gave you something and you had to figure it out. You want another one like that, or are you ready to move on? Huh? Raise your hand if you want another one like this. I'll give you one more, real quick. By now, you ought to be able to just plug and shove. Find the arc ABC. All right. Durden, what you got?
I got 6 points.
Oh, no. Tell me what to write down. We'll get to that.
So 2 pi over, and then you're going to have
2 pi times what?
2.
Why?
That's 3.
Very good. All right. Then it's going to be some number over 360. We're going to go ahead and put that in parentheses. Magic $64,000 question is, what number goes over 360?
180.
180. Very good. Okay. How did you get 180?
Well, I got the missing angle right there that you needed, and then I realized
How?
you needed
What is the measurement of this angle?
135.
Why?
Because you subtract it from 180.
Why?
45 from 180.
Why?
Because it's a straight line.
Why?
Supplementary angles.
They are supplementary. You're on the right track. LP, they are a linear
There.
pair. They are a linear pair. So anybody find that this angle was 45 degrees? Okay, some of you. Why is that angle 45? By vertical. Should you have known that if AC is a straight line, instantly we're just looking for half the
I
circumference?
didn't want to assume.
Okay, that's fine, but this reduces to half, right? It makes sense. We're not talking about all the way around this circle. We're just talking about half of the circumference. So we find the circumference is 4 pi and we take half of that, right? 2 times 2 is 4. 4 pi times a half, these cancel and I just get 2 pi. That's my exact answer for the arc length of ABC. Rounded like money, you get 6 point what?
2.8.
628. Okay, very good. Questions? Are we good on arc length? Okay, now what am I going to do? No, we're not going to play quizzes and do practice. What are we going to do in relation to this formula? Why have the examples I've given you been easy?
Because it's the beginning.
What did I give you?
They're minor.
I gave you the radius and I gave you the ratio, the easiest kind, right? I told you in the very beginning, they got to give you 2 out of the 3. So this time, I'm going to say that the arc length is 42. I'm going to tell you that the radius is unknown. And I'm going to tell you that the ratio is 60 over 360. For example, this is what that picture would look like. Right? Here's AB. I tell you that this distance is 42, we'll say 42 inches. And I told you that this was 60 degrees, and I said find R. Right? How is this problem different? Well, you've got to work backwards. You've got to manipulate that formula to be able to solve for R. Right? Here it is. Right? 42 is the arc length. 60 is that central angle measurement, which means that AB's measurement is 60 degrees. How do I isolate R? I can do it in one step. How do I isolate R in this problem? I'm going to write it like this again. 2 pi R. And then 60 over 360. Give myself a little room. Here we go. Anybody have an idea? Megan Johnson? Outstanding. I don't want to do that first though. It doesn't matter. You can do it. But just by preference, I'm going to multiply by 360 over 60. That is the reciprocal. Right? These cancel and these cancel. So I multiply this by 360 over 60. If I do it to one side, I got to do it to the other to balance it out. Where? You could, right? Barry figured out that that's just 6 times 42, which is fine. Let's leave it like that for now, because it won't always be a nice number. What if that was a 58? So we'll leave it like that for now, but that's fine. Okay, am I done? Is R by itself? No, it's being multiplied by 2 pi. So Megan, what am I going to do now? On both sides. I would prefer you say it like that so that we kind of get in the habit of knowing that we're doing it to both sides. Right? When I taught algebra, it was mandatory. You must say, you do that to both sides. You do that to both sides. Right? You divide by 2 pi to both sides. Right? Understanding that they cancel over here, and over here I'm dividing by 2 pi. So literally in one step on your handy dandy calculator, you should be able to type all this in. Parentheses 360 over 60. Type it, try it now. Times parentheses 42 divided by parentheses 2 pi. Parentheses are imperative if you want to get this problem right. Okay, imperative if you want to get this problem right. Plug and chug and tell me what the radius is. How much? Round like money, it's fine.
1.1.
1.1, is that right?
Just kidding, maybe not.
I have a question. Whenever you put your parentheses, like,
Oh, just kidding. I'm putting all.
you have to put your parentheses between like the multiplication.
I always, right here on my calculator, I put a times right there. Is that what you're asking?
No, like on the
Oh no,
top.
you can smush the multiplication, the parentheses together, and it knows to
I
multiply.
got 40.12.
Okay, that's what I got.
Yeah.
Actually, 40.11.
I put 6 here.
I'm almost there. Give me a second.
Could you make it 6 over?
40.11,
Yeah, that's what I got.
rounded like money, it would be 40.11. So the radius is 40.11. If the arc length is 42, if the measure of the central angle is 60, and that means the measure of the arc is 60. Okay? Questions on this problem? Yes?
You always put your
How do we undo any fraction? We multiply by the reciprocal. We multiply by the reciprocal. Okay? So, what did I not give you in this problem? The radius. What am I not going to give you in the next example? The ratio. That's exactly right. Last one, and then I'll let you do some, we'll practice some. Alright, there's your picture. What information am I giving you? I'm giving you the arc length. What else am I giving you? I'm giving you the radius. Most of the time they give you the radius instead of the diameter. What information am I asking you? The ratio or the measurement of the central angle. This degree from A to B, right, here's A and here's B, is also this degree. This degree and this degree have to be the same. Sometimes they put the X out here, sometimes they put the X out here. Sometimes they put the X out here. What would you have to do then? You'd have to find the ratio and then what? From 360. That's tricky. Okay? So you just have to be careful about what they're asking for. All right, who thinks that they can set this up for me and write it all the way out? Maggie, out of the way to volunteer. Here we go. Here's the formula, so plug in. What do you know? Is equals what? 2 pi times what? Why 10? Outstanding, you're doing great. Times what?
360.
Something over 360. What is that something in this case? It's your x. It's your unknown. Right? It's the value that you're trying to find. Right? They're either going to ask you the arc length, or they're going to ask you the radius, or they're going to ask you for the ratio. They've got to ask you for one of those. Okay? Guys, one step I should be able to do this problem on my calculator. What do I do with the 360 to get rid of it? On both sides. Right? That's a requirement. I multiply it there to cancel it out. I multiply here by 360. So I'm going to say 360 times 12. That's some big number. Okay? To bring it back down, I'm going to do what? How do I get rid of 2 times pi times 10, which is times x? How do I undo multiplication? I divide by how much? How about 20 pi? Is it okay to divide by 20 pi? Where'd 20 come from?
2%.
Right. Can you make that jump? Right? That's perfectly fine. Divide both sides by 20 pi. Right? I could do some zeros. I mean, I could do this by hand probably. Okay, and cut it on down. Let's see if I can do it by hand. This 0 and this 0 cancel out. Right? 2 half of 36 is 18. What is 18 times 12? 18 times 12. I used to know that, isn't it?
216.
216.
Yes.
I got
18 times.
18 times 12 is how much I use.
Okay.
678.
Do 360 times 12 divided by 20 pi and see if you get the same thing.
I got 678.
Let me see. 360 times 12 on the top and 20 pi on the bottom.
Yeah, I got
68.75.
Does this reduce to 68.75? Is that right?
Yeah.
What is that telling us again, Turner? What measurement is that 68.75 supposed to be in? But what measurement? Is it inches or centimeters? What does it have to be in? It's degrees. Why? Because it's that measurement right there. It's in degrees. It's that angle measurement. That means from this line over to this line, even though it doesn't look like it, is approximately, we'll say 69 degrees. Right? If I rounded to the nearest degree, it would be 69 degrees. Okay? So, they're either going to give you the arc length and ask you to find the ratio or the radius, or they're going to give you the ratio and the radius and ask you to find the arc length. Okay? Questions? Anybody have any questions? All right.